Hey there. Here we're going to be going over some of the more common drug discovery use cases for medicinal and computational chemists. The default loading configuration of Nanome attempts to find the ligand, increase that selection by 5 angstroms, and then render those residues and waters. This particular structure is known as a kinase, specifically TNNI3K. When you load a structure in Nanome, it's broken up into three parts: the protein, the solvents, and the ligand. Let's go ahead and select the ligand here by pressing on 4CW with your index finger. Open up our macro, find the ligand prep macro, and press run. This will duplicate the base ligand and keep so that you can keep the original one intact. I'm going to go ahead and hide the duplicate and keep turn on the original. Now I'm going to go ahead and transition over to open the modify panel. Put that on the left, lock that in place, go to the tool section, and open up the Mechem tool. Typically, you'll start here on the left. We're going to go ahead and select the structure here. You can see that it's selected by that green highlighted state. And I'm going to get the frame data. Okay, and I'll go ahead and lock that in place and transition over to the Edit tab here. Next, I'll go ahead and open the View Chemical Properties and put that up there. Perfect. We're going to go ahead and select this ligand here, which will render a 2D representation of this 3D structure, as well as provide you some chemical properties, such as molecular weight, lipophilicity, total polar surface area, solubility, hydrogen bond acceptors, hydrogen bond donors, rotatable bonds, and aromatic rings. This is an integration through our Python API with RDKit. I'll go ahead and take a snapshot and view the snapshots. Open the View Snapshots table, so we can get a good view at this. This is a great way to keep track of some of our changes and the chemical properties associated with those changes. I'll then go ahead and turn off minimization here, go to my build tab, and then, so one of the things that the research team working on this structure wanted to do to increase potency was replace this nitrogen with a carbon. So I've gone ahead and hovered over my carbon here, press on my index trigger finger, and then hover over the nitrogen there. And as easy as that, it's now been replaced. The other thing they wanted to do was change that single bond to a double bond. So I'll go ahead and hover over my double bond here and place that there. Perfect. Go ahead and make that larger so you can see. Now, the other thing they wanted to do was add a morpholine here. And the reason they knew to do that is because they had a decent understanding of the structure, the pocket of this structure. So let's go ahead and render the surface of the structure. And we're going to do that by inverting the selection of these double arrows here on your entry list. You can also just select the protein there. And let's go ahead and turn on our display menu, increase the opacity, and then show surface. Perfect. So here you can see how well this pocket, this small molecule fits here. I'm going to go ahead and add one more of the changes that the scientists made, which is add a bromine here to this carbon. So go ahead and do that. And then duplicate the frame and take a snapshot of where we're at. Notice how, by making those changes, the molecular weight has increased from 312 to 388. Finally, I'm going to go ahead and turn off the surface real quick. I want to show you how another typical thing is done, which is the measurement of these H bonds. So I'm going to go over here to my tools menu, pick on the H bond, pick on the measurement tool. Make sure that you're on the distance mode. I'm going to deselect all by clicking on the sky. And then hover over this nitrogen, and then hover over and click with my index finger on this oxygen here. Do the same here, and you can see that this is 2.8 angstroms. This is 2.73. Now that those are selected, I'll go ahead and turn on or apply a minimization to this small molecule. So let's transition back to the MedChem tool, go to the prep panel, and then turn on auto minimize. Notice how the measurements update in real time as it's optimizing the geometry of the structure. We also get these red cubes, which indicates that a calculation has just happened and these structures are locked to each other. We can turn off those boxes by making sure they're both selected on the entry list and turning off the toggle here on this cube. Let's go ahead and remove these measurements. And delete that, transitioning over to the deletion mode. And then finally, the morpholine that they wanted to add here, let's go to the Mechem, can be found by going into the Build tab and then going over to our library, which has several options, right? Carbon molecules, amino acids, functional groups, custom rings, or you could just search for it here. So I'm going to type in morpholine. You can see you don't even have to type in the whole thing, and it shows up here on the right or left. I'll then go ahead and close this, and then rotate this with my joystick here, and then position, click and drag, and perfect. And then we'll go ahead and take another snapshot of that and duplicate the frame again. So notice how we now have these frames here, which you can cycle between the different designs, as well as look at the different properties for those design choices. Now, if we wanted to export this table, which includes the smiles data, you can press on this export CSV. And if we wanted to export the designs of the small molecule, you could go over here to the frames. Let's go ahead and let's say we wanted to export this first model. You can see that by clicking on these different frames, you're cycling through those both here and on the frame menu. And let's say that the example with the morpholine is our favorite one that we want to export. You can press on this export frames, and you can choose to export in PDB, MMSIF, SDF, Smiles, and choose the export location. Also notice that, as we were making changes to the small molecule, it was actually updating in real time the 2D representation there. And then, so you could change the name and then press export. Perfect. Hope that was helpful. If you have any questions, feel free to reach out at support@nanome.ai. Thanks.